Now, before we can get into what hypothesis testing is and how it works, it's going to be important for us to understand how hypotheses work. And we have very strict rules and guidelines for how hypotheses are going to exist. So recall, first of all, from chapter 1, that a parameter is a numerical summary of a population. There are 3/4 big parameters of interest for us. And what are they? Okay, so we learned mu, which is the mean, technically population mean. We learned in chapter 6 and then again in 8 the p, which is equal to, oopsie, hold on, what did I just do? P, there we go, which is equal to the population proportion. And then we've got 2 more. We have sigma squared and sigma. So these should be looking familiar to you because they're the same ones that we dealt with in chapter 9, right? The same ones we would want to make confidence intervals for. Now, sigma squared is equal to the population variance. Sigma is equal to the population standard deviation. Now, why do we really only talk about 3? Well, it's because variance and standard deviation really aren't any different from each other. When one goes, the other one follows, right? So you can kind of think of sigma squared and sigma as being basically the same thing. That's why I said there was only 3. Technically, it's 4, but variance and standard deviation have no real mathematical differences other than one squared and one isn't. Now, the null hypothesis is read H0, H0, as in all for naught. It's a statement to be tested. The null hypothesis is a statement of no change, no effect, no difference, and is assumed to be true unless evidence can prove otherwise. So, for example, in our little experiment, we assumed the dice are fair, or the dice roller applet or whatever online is fair. That's what you assume to be true, unless we can prove it otherwise with data. Okay? So the alternative hypothesis would be what you would suppose if the dice were not fair. Right? So it's read H1 or H. Some books will have it H lowercase a, here, like this, like that. Some books will say 1, either way. All right, and what it is the dice, dice are not fair, i.e. dice are rigged or loaded. There's the alternative hypothesis. Okay? Now that's written in words. Of course, we're not going to be writing in words for very long because we're mathematicians and everything has to get changed to a symbol. But suffice to say that when you do write it out with symbols, there's 3 main ways you can write it. A right-tailed, a left-tailed, or a two-tailed test. A right-tailed test has the alternative hypothesis as a greater than symbol. A left-tailed test has a less than symbol, and a two-tailed test is a not equal to symbol. Notice that the null hypothesis is always equals no matter what. See how they're always got the equality in there? Every time, no matter what. And every time you see the word parameter, it's going to end up being one of these symbols. Mu, p, sigma squared, sigma. There are other ones, but those are the ones that we're going to be concerned with. All right, so let's look at this particular case. Panels of jurors are theoretically drawn from a list of eligible citizens. However, in the southern states in the 1950s and 60s, few African Americans were found on jury panels, so some defendants challenged the verdicts. During one such appeal hearing, evidence was given that 50% of jury-eligible citizens in the county were African American, but on an 80-person panel of potential jurors, only 4 were African Americans. The defense attorney argued before the judge that the jury panel was rigged. All right, so let's state the null and alternative hypothesis. And by the way, if you're ever interested in this particular problem, I got it from the Cartoon Guide for Statistics, which is an excellent book. So we assume that the jury panel was fair. Okay? If that's the case, then what proportion should be there? Let's write it out in symbols. It should be that the proportion of African Americans is equal to 50% because that's what it was in the county. The alternative, H1, is that the jury was rigged, which would mean the proportion was significantly less than 50%, which is what it should have been if it would have been a fair representation of the county. And this is a left-tailed test. All right, I'll see you back here next time.